If you told me that this was a planet and asked me if it was Earth-like, I would tell you, yes, it's Earth-like because it has two features in particular. One is lots of liquid water, which I would assume would be this blue stuff. And the other is this stuff. So I would tell you that because it has plate tectonics, because it has the ability to recycle nutrients that life needs, that it's also an Earth-like planet. So an Earth-like planet can be defined in different ways, and it really depends on who you ask. So for example, if you ask me as an isotope geochemist what an Earth-like planet is, I would tell you that an Earth-like planet is a planet that has the same chemical and isotopic abundances as the Earth, which is very different than asking what's an Earth-like planet in terms of a planet that has life.
So when I think of what does an Earth-like planet mean to me, I'm thinking about its mass, its radius, what kind of star it orbits. From my perspective, one of the most important ones is the surface temperature, and that we can have liquid water. That has seemed to be really important for having life on our planet.
For me, an Earth-like planet is not a binary, it's a spectrum. You're not either an Earth-like planet or not an Earth-like planet. It's really difficult for me in this framework to try to pin down one single characteristic that is most important to making an Earth-like planet an Earth-like planet. I would probably say that it's the ability to generate novelty, new phenomenon and processes that come into existence that can then have a chance at coupling with the rest of the phenomenon at play on that world.
So as an astrochemist, I would consider the chemical composition of a planet to be important into whether or not it's Earth-like, so how much carbon, nitrogen, oxygen is in the planet relative to heavier elements like silicon, magnesium, and iron. And this might be important for the structure and evolution of the planet, but also for its ability to potentially host Earth-like life.
For me, an Earth-like planet is something that has the features of the Earth. So not only its mass, its density, its composition, but also some aspects of its evolution. For example, Earth has plate tectonics, it has liquid water in its surface, and it has had a magnetic field for as long as we can tell. And it also has life, of course, and I don't think these things are coincidences.
The reason why we care about Earth-like planets to begin with is because we want to know our place in the universe. We want to know if we're alone. We want to know if there are other planetary bodies that could harbor life.
I think that Carnegie Science is a great place to ask this question because we have such a diverse and large range of scientists who are all coming at this question from so many different angles that together I think we can really start to answer this very complicated question.